So for these mixture problems, I want to give a scenario. Okay, so if I go to the store and I buy my kids some juice. Okay, let's say it's not pure juice. If I buy 1 gallon and it tells me it is 50% juice. How much actual juice is in that container? Half a gallon. Okay, let's say I bought a 2-gallon jug and it was 25% juice. How much actual juice is in there? Half a gallon. In 1 gallon it would be a fourth, right? So in 2 gallons it would be half. You guys agree with that? Okay, if I had 5 gallons and it was 75% juice, how could I find out? What would I do? In 1 gallon, how much juice would there be? 3/4, so 0.75 or 3/4. So in 5 gallons, I would have to take that times 5. So what's 0.75 times 5? Is that what we really did every time? We took the 1 gallon times 0.5 and that gave me a half. If I take my 2 times 0.25, we get our half. So the formula that we are going to use on these mixture problems is our amount. That's like your gallons or liters or something like that, times the concentration. Your concentration is your percent, equals the amount pure. How much actual juice did we have?
Can I get some notes?
Yep, in the file over there, the pre-calc folder. The one on the left. Okay, so if it were me, I would write this formula down next to these mixture problems. This is what we are going to be using every time. Was it in there? I have an extra one on my desk still.
Thank you.
All right. Let's look at a problem. All right, so a lot of these situations are chemistry type problems when you're mixing different chemicals or diluting different solutions. So if we look at this one, how much of a pure alcohol should be added to 20 liters of a 40% to increase the concentration to 50%? Okay, so what we have going on here, we have two different things we're mixing together. We have the pure solution and we have the 40% solution. And I'm trying to get a 50% solution in the end. That's a lot of information. So my suggestion on these is create a table to help organize all of your information. Does that mean you have to use a table to solve it? No, but I will every time. And if you create the table, it will actually make your life a whole lot easier. All right, so my rows of my table are going to be the things that I am mixing together. So I am mixing the pure solution with a 40% to get my total, or my 50%. Now, I don't care exactly what you label those. If you want to call it first, second, and total, that's fine. If you want to call it pure, 40, and 50, that's fine. But they need labels. This is how I'm defining my variables here, by labeling it in a table. If I don't know what your rows and columns represent, then your table isn't labeled. Across the top, I'm going to put the formula we're using. The amount times the concentration equals the amount pure. So anytime we have a lot of information, this is my strategy. So now we go back to the table, to the problem, and we see what we have. How much pure alcohol? So I don't know how much. So what would I put for my amount? X. We don't know, so it is X. Should be added to 20 liters of the 40%. So the amount of my 40% is 20. Now, my concentration. If it is pure, what is my concentration? 100%. We always move it to decimal form, so 100% would just turn into 1. 40% would be 0.4. My total is 50%, so 0.5. I need to figure out what to put here. If you put in 5 of the first and 20 of the second, how much do you have altogether? 25. How'd you get it? 20 plus 5. So if I'm putting in X of the first and 20 of the second, we just add them together. X plus 20 or 20 plus X. So my variable is defined. I can look at this table and say, okay, in this problem, X is the amount of the pure solution. Now to get this final column, we just follow the formula. Amount times concentration. So X times 1. 20 times 0.4. You can go ahead and work it out for the sake of your notes. I'm just going to write it in here in case anybody's looking back and wants to know how I got that. But if you want to go ahead and write 8, that's fine. And the last one we're going to do 25 times our X plus 1. Well, not 100. All right, if you can get this column, your equation basically writes itself. This is the amount of pure I had from the first one. That's the amount of pure I had in the second one. So if you add those together, it equals your total. So my equation is X plus my 0.4 times 20 equals my 0.5 times X plus 20. Or if you've already multiplied that, X plus 8 equals 0.5X plus 10. Now we solve our equation. Subtract over the 0.5x, subtract 8, divide by 0.5, and you get what do I need to do now? How do we always answer it? Sept. Yep, word form. So if I look back, the question was how much of the pure, and that's what X represented, so there must be 4. Okay, 4 was in my amount column, so my amount was measured in liters here. So we need 4 liters of the pure solution. Any questions on this? So I strongly recommend the table. We're going to use this when we solve other types of problems as well. Just anytime we have a lot of information, it is very helpful for organizing it. So our next question, how many liters of a 25% antifreeze solution should be added to 5 liters of a 10% solution to obtain a 15%? There's a lot of percents in this problem, but what should we start with? Table. Let's organize our information. Across the top, we put our formula. You do have to write your formula. That's how it counts as labeling your variables. So amount times concentration equals amount pure. All right. What would I call my rows? We have a 25% should be added to a 10%, and our total should be 15%. Just a hint on these problems. When I'm looking at these, even if I don't read the problem, I know what percent has to be my final one. Your total concentration has to be a number in between the other two. Okay, you are going to mix something of high and low concentration and get a number in between. So even if you didn't read it, if I told you you had a problem and your percents were 90, 12, and 20, can you tell me which one is the total? 20, because it's between 90 and 12. Okay, if I said I had 5, 8, and 10, which one has to be my total concentration? 8. So your final concentration is always a number in between the other two. All right, the amount. How many liters of a 25% solution? So I don't know it. I would call that X. Should be added to 5 liters of a 10% solution. So my 10% is 5 to obtain a 15% solution. So if I put in X of the first and 5 of the second, how much do I have in my total? 5 plus X, or X plus 5, doesn't matter. Okay, concentration is just your percent in decimal form, so 25% would be 0.25, 10%, 0.1 or 0.10, 15% is 0.15. And our formula, amount times concentration, so we just multiply 0.25 times X, 5 times 0.1, 0.15 times 5 plus X. You're welcome to go ahead and multiply those. For the sake of the notes, I'm leaving it in this form so you can see where my numbers are coming from. And then, how do I write my equation? Always the first plus the second equals the total. So if we multiply out, and if I subtract over my 0.15, we get 0.1x equals 0.25 divided by 0.1, and x is 2.5. Then you just have to make sure you answer the question. So I wanted to know how many liters of the 25, that was what my X represented. There must be 2.5 liters of a 25% solution. questions on that one? I want you guys to read this one and see if you can set up the table. So formula, amount times concentration equals amount pure. Okay, the things we're mixing. How much water? So water should be one of these rows. Should be added to 20 liters of 18% acid solution. So I have an 18% solution. And my total, I want to reduce it to 15%. So I'm trying to get 15% for my total. It starts off how much water. So what should I put for my amount of water? Okay, should be added to 20 liters of the 18%. So what would my total be? All right. Water, concentration. If you go get a drink out of the water fountain, what percent acid is that water? I hope it's 0, right? Water shouldn't have anything else in it. We hope, yes. So, water is always a concentration of 0. Pure is always a 100% concentration. 18% would be, and 15%, 0.15. So we multiply x times 0, 0.18 times the 20, 0.15 times the x plus 20. How do we write the equation?
0 plus 20 times 0.18 equals 0.15x plus 20.
Perfect. So 0.18 times 20. 0.15 times 20. Let's get 4. So when we answer the question, we want to know how much water so we need 4 liters of water. Questions? How are we doing with these? Okay, here's what I want to do. I am going to do another problem, but I'm going to let you guys work on homework first because the other problem is a little bit different. Okay, so I'm going to give you guys a little bit of time to work on some homework questions. Then keep this notes handout out. We will come back and do that. You did 1 through 4 yesterday. So right now, for now, I want you to add 5 through 7. You have been tasked with creating an innovative dairy beverage. I actually took this question off one of Miss Brandt's food science competitions. So you have 30% heavy cream and 3.5% fat milk. Your target dairy product should have 7% fat. Okay, so everybody make sure you're with me right now. I'm gonna look at this. If you just look at these percents, can you tell me which two you're mixing together and which one's your total?
Yeah, 30%, 3.5, and total is
Good. Amount times concentration equals amount pure. I'm mixing together 30% and 3.5% to get my total 7%. So it says you will be making an 8-pound batch. Is that the amount of 30%, 3.5%, or my total? Total. Okay, my concentration, 30% would be 0.3. 3.5 would be 0.035. What would I put for 7%? Okay, this one's a little bit different. I didn't tell you how much of either of those. I can't make them both X though, because did I tell you you were adding equal amounts? No. Okay, so let's say one of them is X. If I put in 2 of the first, how much would I add of the second to get 8 altogether? 6. How'd you get that? Okay. So if I have 8 in my total, this would have to be 8 minus X. The total minus the amount I've already used. So now if we multiply, we have 0.3x, 0.035, 8 minus x, and 0.07 times. And our format, the same every time. We add the first and second to equal the total. 0.3x plus 0.035 times 8 minus x is 0.07 times 8. Everybody with me here? Am I in like terms? So if I subtract those, I get 0.265 x. Subtract over my 0.28. Divide 0.28 divided by 0.265 doesn't work out perfectly. 1.06 if we rounded. So how much cream will the batch require? Cream was, we look back, the 30%. So that's what's our X. So the batch needs 1.06, what was I measuring in? Pounds of cream. All right. So you should have the problems from yesterday and 5 through 7 done for tomorrow.